In part 2 of this video, we're going to continue looking at applications of quadratic equations. We're going to look at rectangles and triangles, so we're going to visit those formulas that we learned in high school probably, that we know that the area of a rectangle is base times height, or length times width. And we also know that the area of a triangle is 1/2 base times the height, but I'm going to introduce a little different version of that and make it 2 times the area equals base times height. But let's hold on to that. Let's look at problem number 6. We did the first 5 in the part 1 of the video. Number 6 says the area of a rectangle is 35 square feet. The length is 1 foot less than twice the width. What are the dimensions? Well, anytime you have a sentence that's comparing two things, like the length and the width, whatever's mentioned last in the sentence, it's the easiest if you let that equal to x. So I still need to define my variable, and I'm going to do that by drawing a picture. So that's going to be my width. So this other side is going to be my length, and it says the length is 1 foot less than twice the width. Well, if the width is x, twice that is 2x, and 1 foot less than is you want to subtract 1. Less than, you want to subtract at the end. Right? Go back to the area was 35 square feet. So how do you get to the area? You want to multiply that length and width. So I want to multiply these two things. So x times 2x minus 1 equals 35. I'm going to multiply that out. I'm going to bring the 35 over because it's a quadratic and set it equal to 0. Now at this point, if you can factor it, I think that would be the easiest route. But this one you cannot factor, and there's going to be some on your classwork that you cannot factor. So I'm going to use that quadratic formula. So I'm going to identify A, B, and C. Remember A, B, C. And let's write it down. X equals the opposite of B plus or minus B squared. When you square a negative, we have positive, minus 4AC, all divided by 2A. Now I see two negatives here, so that tells me I'm going to add underneath that radical sign. So I have 1 plus, that's 70 times 4 is 280 divided by 4. So I have x equals 1 plus or minus the square root of 281 over 4. Now I'm going to finally ask you to get out your calculators. We're going to get a decimal approximation. Now before I punch anything on my calculator, I want you to notice that that's a plus or minus. So I have x equals 1 plus the square root of 281 over 4, and x equals 1 minus the square root of 281 over 4. And I'm going to do that one at a time on the calculator. So let's do the first one. We have 1 plus the square root of 281, and I'm going to punch enter because at that point if you just punch divide by 4, you're going to get it wrong. So I'm just going to now divide by 4, and the calculator takes the previous answer and divides it by 4, and I get approximately 4.44. Now let's do the other one. We have 1 minus the square root of 281, and notice that that's a negative 15 divided by 4 is going to be negative. And can a width be negative? No, it cannot. So we're going to throw that out and say it cannot be negative. So x is 4.44, but it also says find the dimension. So that's x. I need 2x minus 1. So 2x minus 1. So I'm going to take 4.44, multiply that by 2, which is 8.88, and subtract 1. So those would be the dimensions of my rectangle, approximately. Again, if you could factor it, I think it would be a lot easier. Alright, let's look at problem 7. Talks about a triangle. We have the height and the base, and we're asked to find those two things, knowing the area is 5 square inches. So you probably learned that the area of a triangle is 1/2 base times height. And that's okay, but I know a lot of you don't like those fractions. So you can get rid of those fractions by multiplying both sides by 2 and writing this formula as 2a equals base times height. And that's the formula I'm going to use. And if you do that, you just need to be careful and not lose that 2 with the a. Now I'm going to draw a picture of my triangle. It's not necessarily a right triangle, but I know this bottom part's going to be my base and the top part's going to be my height. So let's go back and read it. It says the height of a triangle is 2 inches more than 3 times the base. So since base was mentioned last, that's going to be x. Now I go back, the height is 2 inches more than 3 times the base. So 3 times x, and then 2 inches more, which means we're going to add 2. Remember the last problem was less than, subtract, so more than, add. And it says the area is 5 square inches. Alright, so using this formula, it says 2 times the area equals base times the height. So again, just multiply that out, set it equal to 0 because it's a quadratic. I look at that and see if I could factor it. I don't think so. So again, I'm going to use that quadratic formula, the opposite of b, so that's going to make it negative. But when you square it, it's still positive. So b squared minus 4ac all over 2a. I see 2 negatives in there, so that means I'm going to add underneath that radical. So let's see, 4 times 3 is 12, times 10 is 120 over 6. Now usually if we weren't using a calculator, you would have to simplify that 124, break it apart. But since we're going to use the calculator, it's actually easier if you don't simplify it. So again, we're going to have 2 answers. We have x equals negative 2 plus the square root of 124 over 6, and x equals negative 2 minus. Now what's going to happen here? You're going to have a negative 2 and you're going to subtract something even bigger. So that whole thing's going to be negative divided by positive is negative. So that is not going to be an acceptable answer for our base. So let's go to the calculator and punch this in. When I punch in negative 2, I have to use that symbol, so negative 2 plus the square root, which means I have to do my second button because my square root symbol is above my key, 124. And I'm going to punch equals because again, if I divide by 6, that's going to be too soon. It's not going to be the right answer. Now divide by 6. So I get about 1.52. That's x. Now I need 3x plus 2. So I need to take 1.52 and multiply that by 3. So I'm going to use my calculator. So 3 times 1.52, and then I'm going to say plus 2. So I get about 6.56. So I have my base and my height. So my base again is about 1.52 and my height is about 6.56. You actually could check that on the calculator if you multiplied those two together, base times height, and divided by 2, took half of it. It should be really close to 5. Remember, it's not going to be exactly 5 because we did round in the decimals. Our last problem revisits something we did in a video before this, dealing with work problems. We basically have this formula, 1 over time alone plus 1 over time alone equals 1 over time together. Now that could be people or machines working together. In problem number 8, we have 2 pipes. One pipe can fill a reservoir 2 hours faster than another pipe can. Together, so we know this one, they can fill it in 5 hours. So we know that part. So now we just need the time alones. How long does it take each pipe to fill the reservoir? Now I think it might be easier if we call maybe this pipe A and this another pipe, let's call that pipe B. And again, as we're comparing it, it says pipe A can fill it 2 hours faster than pipe B. And since pipe B was mentioned last, let's let that be X. Now that's the time alone. So X is the B pipe alone. Now pipe A, it says 2 hours faster. Now a lot of students get confused with that and they want to add 2, but let's just stick in some numbers. What if pipe B could do the job in 10 hours? Well, pipe A, if it's faster, that means it could do it in less time. Faster, less time. So we're going to subtract. Now remember, that's not the answers. I was just plugging in some arbitrary numbers. So if pipe B is X, 2 hours faster would be X minus 2. So now we have those time alones. So we have 1 over X plus 1 over X minus 2 equals the 1 over time together is 5. Now we have a rational equation. So in order to solve that, I need to multiply by the LCD, which remember is 1 of everything. So I'm going to multiply every term by my LCD so I can reduce and get rid of the fractions. So don't lose that 5. Here the x minus 2's cancel out and we have 5x. And here just the 5's, but don't lose that x. Right, so I distributed. I'm going to collect like terms. Now I have to set it equal to 0, so I'm going to subtract 10x from both sides. So I get x squared minus 12x, and I'm also going to move that negative 10 over to the other side. It becomes positive, and that leaves me 0. And one more time, I cannot factor that. I need to use the quadratic formula. And notice my b is already negative, so when I put it into the formula, it does become positive because it's the opposite of b. b squared is 144. I notice I have only one negative sign, so that means I'm going to subtract underneath that radical. And now I'm going to use my calculator. Once again, if we weren't using our calculator, you would need to simplify that square root of 104. With the calculator, it's just easier again to leave it there. And we're going to have two answers. Remember, we have 12 plus the square root of 1 over 4 over 2, and x equals 12 minus, right? And remember, we need x represents, I believe, pipe B. So let's see what happens when we punch those into the calculator. So I'm going to have 12 plus square root of 104, enters or equals, and divide by 2. So this pipe is about, let's call that 11.1. Now let's do the other one. It might not be negative. Let's see, we have 12 minus the square root of 104 and then divide by 2. Now that's positive and it's about 0.9. Now that was pipe B, but pipe A up here says x minus 2. So if this is x, then x minus 2 is going to be, so 11 minus 2 is about 9.1 hours. Right? So we have pipe A and pipe B. Now, if pipe B is 0.9, x minus 2, that's 0.9 minus 2, and that is negative. So even 0.9 was positive, we still can't use it because we end up with a negative answer for pipe A. So the only two acceptable answers are 11.1 approximate hours and 9.1 for pipe A. And we're done. So we finally get to use our calculator.